Good afternoon, everybody. Welcome to UQRUG number, I think we're up to 49, I think is this UQRUG, which is nice and exciting. It's not an exciting number, I guess, but yeah, this is the April UQRUG. For those who are new to RUG, the UQR user group is a gathering where we all come together to help each other with our problems. So we solve problems, share resources, share tips, and simply hang out with each other in this little community. If you're here and you're just listening in the background and doing some coding, that's also totally fine. As you will be very aware, we meet the last Wednesday of every month from 12 till 2. We meet both online here and in person over there in the Central Library at UQ. Yeah, this is us. So today what we'll do is we will get everyone to come along to the Hedge doc. So I'll put a link in the chat to that Hedge doc. This is the Hedge doc that I'm referring to, actually. And the chat's over there. Oh, we've got it sending to a private message. There we go. Everyone in the meeting. There's the Hedge doc. The other way to get to it is to just Google UQRUG. You Google or do a search on your preferred browser of choice. UQRUG, we want this one here, not UQ Rugby, but this one. And to get to the Hedge doc that I just put in the chat, you can click on this little button up in the top corner where it's got a little document, or go to the link I put in the Zoom chat. So the reason we have this is our landing page. This is our website where we've got all of the details of upcoming events like today's event, past meeting notes from previous ones, links to other community groups that you can get in touch with. So we've got a bunch of other community groups that you could engage with that may be able to help you with the related issue that you're having. We also have our YouTube channel, and that has recordings like the recording that we're going to make from today's session. And so you can check out the previous recordings of the UQR user group there. So if you do want to learn about web scraping or any of the other things that we run, you can just watch the little start part that we have there. On that note, if you don't want to be included in the recording, please send me a message and let me know. That way we will edit out any bits that have you talking or anything like that. I don't want to discourage people from engaging, so please do engage and just let me know if you want me to clip anything out. All right, let's go through to the Hedge doc. So the Hedge doc is a little collaborative pad that we can all edit in. Now, if you go to the Hedge doc for the first time, you will see, and I can't show you because it's not the first time for me, you'll see in the top right-hand corner, there'll be like a little blue pencil. You just need to click on that blue pencil, and that will allow you to then edit the Hedge doc. Now, the reason I want you to edit the Hedge doc is so that you can come through here and add your name to the list of people who are here today, which, well-oiled machine, most people have already done so. Well, not most people, but a lot of people have already done so. But before we jump through to that, we'll keep talking about what we're going to do today. So we're going to do 4 things today. We're going to start today by having people add their names to this page. Then we'll have people add their questions onto this page, which we can answer at any point in time. And we'll go to our intro to an R package. So I'll talk a little bit about that in a moment, but we've got our guest here, David Green from the Research Computing Center, who will be talking about using R on the high-performance computers that we have at UQ. And then once we've done through that, which will be about half an hour or so, we'll have questions that people have brought along. So answering those questions. And that can be ones that have come up because of something interesting David's brought up, or just something you're needing help with today. So if you are there in person, I'll encourage you to also join the Zoom meeting if you have something you want to share. That way you can share your screen. But if you're just happy to hang out there in person, that's fine too. All right, so let's go to the first part. Let's add our names to this page. We do that by, like I said, clicking the little blue button up in the little blue pencil that'll be in the top right corner. And then change it to, once you've done that, you'll be able to change it to split view mode. Now, this is where we can go and edit this code here. So for those who don't know, this is Markdown, which is a form of markup language. HTML is another markup language for those who don't know. Basically, what it allows us to do is edit text in a really simple way. So 1 hash here will make a title, and 2 hashes make it a second level heading. You put 2 asterisks around a set of text and it will bold it for you. You can add links, all sorts of different things. What we can also do is add tables. So down here, people are already adding themselves to the table here, which is awesome. And I'm going to add some more lines to the table. And you do that by just putting 4 bars. So that's the pipe, the little symbol that's on my keyboard is Shift backslash, the one above the Enter key on my keyboard. And you simply just add your name in there, put where you're from in the middle one, and then what brings you here today. So we've got a good variety of people here. So yes, please do add your name to this because it also helps us with numbers. We get an idea of how many people have come along, and it means that we can make sure we promote it and keep it going every month. All right, looks like almost everyone's added their names to that. So once you've done that, what I'll get you to do is if anyone has any questions that they've brought along today, please go ahead and add your details into the question section. So to do that, space that down a bit. To do that, what I want you to do is, do it in any order you want. If you don't want to be the first question, you can put it down in question 2. Just throw your name here. So put your name in here. So if your name's Nick, put your name there. Put your question summary there. And then go into details about your question here. So just pop your name in there. The other thing that we can do is once you put your question in, people can then go ahead and add answers underneath. So we're really encouraging everyone to share in ideas. One person may not have the right idea, but everyone working together can often get you there and get the answer to any question that anyone has. That kind of collective Googling is often really helpful. All right, looks like there's no questions today yet. If you do have questions, please go through and put them in. You can do that at any point in time. If you're having any issues accessing the Hedge doc, also just send me a message in the chat and I can try and help you out there. But otherwise, it looks like we've done the first 2 parts of our ways of working today. We've added people's names to the thing, got the questions. So now we'll go through to our intro to an R package. So this month, we've got David Green from the Research Computing Center. And he's going to be talking about how we can use the HPCs to make our R scripts run even faster, as well as some neat little things about the new graphical user interface for using RStudio. So you don't have to learn all of the hard things to make it work. So with that out of the way, I'll throw over to David. I'll stop sharing my screen and I'll let you share, David. And yeah, I'm keen to hear what you have to say.
Great, thanks, Nick. Let me just share that up. I think I'll do the whole, I'm going to be flipping between, do that screen to share, and then you should be seeing a, so I thought, well, there's a bit of an adage in IT sort of circles about, you know, you got to eat your own dog food. So anyway, I've used Nitar to create the presentation, and then I can take the markdown and repurpose it. Yeah, so this is a common. I get to sort of cheer from the sidelines while people go from, you know, using a laptop and get transitioning to becoming you know, confident and competent users of R on the HPC. And it's always very uplifting to sort of see that transition, and that, you know, there are a few you know, challenges along the way. That's certainly you can't underestimate that, but the benefits really are worth it. So what I thought I'd sort of, in terms of sort of an outline for the session. So you know, look at you know, the sort of code you might have, and and often, pardon me, often people are coming in with a laptop that's, you know, really struggling, and they started working on their sort of, you know, their little project. It was becoming, you know, became their sort of, they were sort of, you know, like their little puppy, and they were sort of training it up, and it was getting more and more capable, and then they started to think about what things they might do with it, and before you knew it, the code was far exceeded what you could do. And that's really the point at which you need to stop trying to do it that way, and really sort of embrace the sort of the opportunity of using the high performance computing systems that we have. I might, by way of sort of preface, when I did an analysis of the most popular software that was used in terms of the number of times that it was activated, in someone's session, it was R was ahead by miles. So it is very commonly used on the HPC, and even though it has some support for parallelism within a node and only a little bit to do with GPU, but it's certainly, there's a lot of it goes on, and some really quality work coming out of it. So I thought we'd look at working through basics of high performance computing, how and why is it different, and then look at really the sort of the nuts and bolts of the transition. We can, so that's so basically, it's the starting point is you've worked up some R code, and you've now got to the point where you're trying to do more with it, and your laptop or your workstation just not capable of it. So so the sort of scenario we've got there. So you've got some code. Your supervisor's excited, you're excited, everybody's excited. And you just need to be able to run it. You need to run it more extensively, perhaps for a greater number of combinations of things, or more iterations, or finer time steps, if it's that sort of thing. And you routinely hit limits to do with your laptop. And those limits come in very familiar and sort of formats. There's if you had more cores in your laptop, you'd be able to do you'd be able to use, say, the parallel package to make stuff run over those cores more efficiently, or sorry, it would get more done because you'd be using more cores. But it's a laptop is a laptop. It's actually probably not designed to be a computing device, a research computing device. It's really meant to be a window to other things. You often have insufficient RAM. So particularly if you're doing well, anything genomics, forget it. You really can't. You often can't do that on a laptop with a real data set. Disk space is usually small as well. It might be fast. It might be a solid state drive, but it's not going to be huge. So you don't have much disk space to play with. And I've literally had people complain that basically my laptop is unusable for anything else when I'm running my simulation or I'm running my code. And it doesn't really happen, but literally smoke is coming out of their laptop when they're trying to run their code, and that's always problematic, because you really can't use it for much else. It's just whirring away. You can hear it whirring away, crunching the numbers, and it gets there in the end. But at some point, you are just expecting way too much out of a device which was never really designed to do that. So that's where Bunya comes in. So Bunya is the name, is the kind of project name for our latest high performance computing platform at UQ. It was a departure from our previous practice in terms of procuring high performance computing over decades. Had been, there's a bag of money, got to spend it, and we did. And we bought well for the circumstances, but there was not the same. What we currently have is a more strategic approach. It's factored into capital budget. It's we knew in advance that we were going to be funded for three phases of Bunya, and there'll probably be a phase 4 and phase 5. I suppose at some point we'll sort of say Bunya's getting pretty old now. We better give it a new, we better think up a new name, but certainly it was a strategic choice the university made to fund the infrastructure purchase and to space it out over several years, rather than doing this kind of the previous kind of practice, which was a one big shot. So I thought, just to make a sort of an interesting comparison, I'd compare the numbers for this laptop, which back in the day was pretty good. It was, I remember it was, well, in fact, I got it as a hand-me-down because it was so expensive when we bought it. When that person left, I said, I'll have that because mine's worn out, and there was still good life in it, and it's still going. So it's your typical laptop has an Intel i7 or an i5 or an i3. Its clock speeds, so it's got one socket. Socket means one CPU chip in the motherboard, and a laptop typically has 4 cores, depending on hyperthreading and a few other tricks. It has logical processors that are double that. And 16 gigs of RAM was a pretty big number back in those days. But typically, you only have one. You have one laptop, and so your total number of cores that you have available to you with doing all of your computing on a laptop is 4. Bunya Phase 1, we bought about 65 nodes. Not all of them were these, but 60 of them were. And each of the nodes, so these are our smallest nodes, our dumbest nodes, our oldest ones. They're 96 cores, 2 terabytes of RAM, and there are 60 of them. So you immediately have access to nearly 6,000 CPU cores. You've got to be strategic about how you utilize those cores, particularly a language like R. There are codes out there that can run across multiple physical machines, and that's supported with Bunya's architecture. But for R code, you really are constrained to one node. But you've got plenty of RAM, you've got plenty of cores, and it's a waiting game, and we'll talk about the fact that it's a shared platform. But if you want all of one node, you might end up waiting a little while for that to come along. But then you do the trade-off. I've actually had conversations with people about trading off the time they wait for the speed. Once they get the resources that they're requesting, then their job will run very quickly. And it's the total time, to wait plus run. And sometimes it's smarter to actually ask for less. It's going to run for longer, but it's going to wait for less time. And that was a little sort of empirical model we kind of put together. So phase 1 was launched March last year. February last year. March was when we shut the old machine down, and then all hell broke loose because a lot of people were quite used to the old machine, and Bunya is a very different sort of setup, and that caused us a bit of excitement for several months. So phase 1's been there for over a year. Phase 2 came in early in the second half of last year, I think. And again, just fewer of these nodes, but they're faster nodes. They're more they're slightly different architecture, which is an issue we're going to talk about. But about an additional 3,000 cores of this type, and then Bunya Phase 3 is actually being the procurement contract and so on is being sort of finalised. As quotes and back and forwards and a bit of discussion about the configuration. So watch this space. If you're on Bunya, you'll suddenly see a burst of nodes probably certainly later this year, maybe early in the second half. But that's not all. So we also have some Bunya nodes have 4 terabytes. If you're doing, and I don't know whether you would be doing this with R, maybe you are, but if you're working with genomic data that's of order terabytes, the data set, the nodes have enough RAM to actually read the whole thing into memory and work on it. The other reason why phase 2 there's only 33 of those nodes is because the other nodes that I haven't counted here have dedicated GPU capabilities, and they're getting a lot of work at the moment with everybody's into AI, and part of the reason why it's sort of less relevant to this audience is that R has really limited support for GPU. GPU is a fast evolving field, and to keep an open source project kind of locked onto what the current trends are is actually quite a lot of work for whoever takes it on. But there's a a package called GPU Matrix, which is, as you might suggest, the name suggests, is good for doing linear algebra. So if you've got that sort of thing, then you could look at using the GPU nodes in Bunya for the for the matrix component of your, and depending on how much of it is spent, how much of your wall time is spent on the GPU and not, it may or may not be worth the effort, but it's certainly an option there. If you've got, chat's got some, oh no, there we are. If you have any questions, just throw up. I can't see everybody at the moment because I'm trying. I have issues with my.
I'll let you know if there's anything in the chats.
All right, yeah, thanks.
Yeah,
Thanks.
one was just asking if they could get access to this, and if you're happy to share it, I'll put it onto the UQRUG website.
Yeah, sure.
Awesome.
Okay. All right. So there's an expression that well, usually men in my demographic sort of use, and that's that we're built for comfort, not for speed. Well, HPC is the other way around. HPCs are built for speed and not for comfort. And that takes a little bit of getting used to, but once you're used to it, it's actually not too bad. You get the speed, and it's really not that uncomfortable. But it's a step up in complexity, certainly compared to running stuff on a laptop. But it shouldn't be insurmountable for people in this audience. It's just a matter of applying yourself and kind of knowing the rules and knowing the ways of doing things. And we're getting better at documenting that sort of material, making it available. It's going to be an evolving story because we're and the senior management got very excited about this idea of the completely graphical kind of access. So Bunya becomes in part like a personal workstation that you can use for doing things in a way which is more akin to what you're used to on a laptop than we have had up until this point. So most HPCs, nearly all of them, are a command line Linux platform. That turns people's turns people right off almost immediately. But it's it is a learning curve, and you've got to be capable enough to get on in the environment. But there are some nice ways of working around some of the issues. So you don't have to learn the VI editor if you don't really want to. You can keep editing your codes in more familiar environments, graphical sort of code, syntax aware editors, that sort of thing. But certainly HPCs are almost always a batch mode environment. So batch computing is a bit like when you go to the delicatessen at the supermarket. You go and you take a number off the machine, and then you wait for your number to be called. So you can submit jobs to the batch system, and those jobs are going to sit there and wait until resources are available to run them. And sometimes you wait a very short amount of time, literally minutes. I've had people who've complained about, and then I have a view of their jobs that shows me when it was submitted and when it actually started, and sometimes it can be as quick as 30 seconds. Literally, it's just the next time that the system thinks about what should run next, it then runs their job. But of course, conversely, if you are asking for a very complicated sort of set of resources and they're not available in the configuration that you require, then you can wait, and you can wait maybe 24 hours for a job to start. So the idea is to start a pipeline and to be feeding that pipeline and then just monitoring as jobs finish. So you need to have job scripts. The kind of the analogy with the delicatessen number tag is that you submit a job and you're issued with a number, a job ID number, and those job scripts have got to be created and submitted and submitted to the batch system. Your jobs, whatever your R program is, it's got to be modified so that it can run in the dark, that it doesn't need you to interact with it, sort of the next point. So it has to be able to run on its own. It needs to be able to know where things are find the files, know the parameter settings, know the parameters that your simulation or your computation uses, and then produces. If it's producing output, it needs to produce PDF files, or if it's producing graphs, PDFs or PNG. So you need to think differently, because you don't have that nice little window that you have in RStudio to plot the results when they run in traditional batch mode. Again, it's not insurmountable. It's been a topic of in many an R training course, how to get ggplot to and spit things out as PNGs or PDFs. Many HPCs these days, including Bunya, support interactive use, and that's well, via the batch system. So what you do is you say, I need to work interactively, but I need to do it properly. So one of the things that we'll keep banging on about is that you don't run computing jobs or tasks of any great caliber on the login nodes. So and we'll talk about the structure in the next section. But your access point to a machine like Bunya is like a hotel lobby, and you certainly wouldn't start getting your suitcase unpacked in the foyer of a hotel and make yourself comfortable lying on the sofa. You would be, you're going to go to a more private space, and that's kind of the analogy. So it's possible to, but it is possible. You don't have to do everything with the command line, lights out, non-interactive jobs. You can actually do things, and I'll demonstrate that as we go through. Some HPCs, including Bunya, have fully graphical interfaces. Now, this is a very new thing for us, and we're still having a few sort of wrinkles to iron out. But it's certainly empowering people's research productivity, and we knew it would. And it took a bit longer than we had expected to get it delivered, but it's now very much a key, a feature of some people's work. And I guess the other point to note is that Bunya is, I mean, you can build high performance computers using the Windows operating system. We did have one about a decade ago, but to be honest, it was really not much different. You had to write job scripts that looked an awful lot like Linux job scripts, except they were using Windows NetApp and NetMap commands. It really wasn't the kind of the sort of panacea that everyone thought, and we ended up sort of walking away from it because it really wasn't getting the use that justified the operating cost. Okay, so a machine like Bunya, I think I'll just do a couple of those. Okay. There we go. All fits there now, almost. So a machine like Bunya, it has one or more login nodes. Unfortunately, this version of this picture doesn't have a little there's a dotted box around that virtual machine infrastructure. So these login nodes are actually virtual machines running on a piece of hardware. The management node, the node that is the batch system and the user management, does the user management stuff, is also a virtual machine. So one of the well, there are several things that you can do as a user, and I'm just giving you a heads up, but there are several things you can do as a user that can impact other users, and one of them is to run heavy calculations on the login nodes. Just don't do it. And heavy calculations includes building R packages, includes building Python environments, includes building or compiling code, using configure, make, install. These things are all no-nos on the login nodes, and I've made it my life's work the last week or so to chase people down and sort of say, hey, look, that's really not fair. You need to stop doing that. How about you do this instead? So the place where all the action happens are these compute nodes, and so think of this as the hotel lobby, and think of this as your individual rooms that you've you've booked you book them for a particular period of time. And so they're all connected by this fast, thick kind of network cabling, and you have access to a home directory, some scratch space. So scratch space is disk space that you can throw stuff in. It is quoted, and but use scratch space for unpacking. If you've got data sets that are compressed, you unpack them into scratch. You also have access to your RDM. So if you have an RDM collection that begins with the letter Q, then it will be immediately accessible and automatically accessible from Bunya. So anywhere in Bunya. So the compute nodes, the login nodes, they all see the RDM collections, and they also all see the same home. So when you log in, it's the same home directory. So you have one home directory, and it's the same. It's viewed from everywhere, and that's really quite a powerful thing. And so yes, so we have a mechanism now where you can run R code in here on one of these, and it's a straightforward thing to do. You can also I probably need to update this picture and put the Open on Demand, the Bunya on Demand interface is a kind of like a login node, only it's fully graphical, and then it also initiates a session on one of these. So what you're actually running is a Linux environment within one of the compute nodes. And that's how you can then run things like RStudio fully graphically and be and playing the HPC game within the rules. So just to give you an idea, I ran this yesterday when it turned out when I was busy preparing or started to prepare my talk, there was a system failure. So these numbers were really small. I thought, that's a bit odd. I really didn't expect it to be that low. And then it turned out the machine had got itself into a bit of a funny state, and a whole lot of jobs that were running got vaporized, and a bunch that were queued then tried to run and failed. So yeah, these numbers were much smaller yesterday, but that's typical. So you're looking at 1,000 jobs. Now, a job could be a single CPU, or it could be multiple servers. It just depends on what the person is doing. So that's the sort of scale of it. That's everybody's jobs at the moment. Jobs. I think I've put that around the wrong way. So this box here sort of shows people sort of say, "Oh, how busy is it today?" Well, there's a few things you can do. You can do this sort of SQ trick and look for how many are running and how many are queued. You can also look at the nodes. So this is a report. It's two reports. The general nodes, the CPU nodes, which are probably the ones that most of us are going to be interested in if we're using R. So there's a list of these names, and they're in these various states. So basically, none of them are idle. So every node has got something running on it. These ones all have names like BUN, short for Bunya, and it's 006 through to 100 and something is the 107, I think, is the biggest. Oh no, 116. It must be a GPU one that we've tacked on the end. Yeah. You can see that when there's a mix, there's still hope for you. Your job could start straight away if it's not requiring, if there's a big enough hole, a big enough space for your job to fit into. So it's a question people often ask, and it's always worth it. It's just a matter of whether it's worth hanging around. So if you were waiting for an interactive session to start, then you could go away and make a cup of tea and come back, and it might have already started for you. It is possible to work interactive, so you don't have to do everything through the lights out batch jobs running overnight or whatever. You can do interactive work, but it has to be mediated by the batch system, and that's the way we do that. We do that to fairly share the resources. So running lots of stuff on the login nodes is running any stuff that's intensive on the login nodes is actually a breach of the user agreement that you will agree to when you sign up for using Bunya. So and we'll remind you of that. And sometimes it's an accident. Sometimes they were doing an interactive job and the job timed out and then they didn't realise. But you've got to be in command of what you're doing and be aware of your situation as you're doing it. And so I'll get in early and I'll say that you don't build R packages on the login nodes. And you use the graphical, use one of these interactive graphical usage you can get using the interactive command line. If you do it the right way, you can actually get it to pop up an RStudio session. Probably works better on campus. Doing it remotely over VPNs probably not. Well, it works, but it's going to be a little bit laggy. But if you go with the Bunya on demand, you're using a web browser and you're getting effectively like a little personal workstation within a web browser. So it turns out that you can. I mean, the question that everyone wanted to know the answer to is why can't I use RStudio on Bunya? Well, now you can. You actually always could, I suppose. We didn't have it installed because it was laggy if they used the first method. But the web browser approach is quite good. Okay, so let's get back to your code. So you've got some code, and so potentially now with getting on the Bunya train, you have access potentially to thousands of CPU cores, terabytes of RAM, fast big data, big data sets. If your personal scratch space is a terabyte and I forget how many files. And if that's not enough, then we have a mechanism where you can request if you're a student with your supervisor's support, a project scratch area can be created, and some of those are like 15 terabytes or 25 terabytes, that sort of thing. So we've got a lot of disk, and it's all fast disk, but you can't have it forever. So it's not somewhere where you keep stuff that's important. It's where you unpack files. It's where you keep data sets that, a bunch of people in a research group might need access to the same input files. Well, it's crazy for individuals to have their own separate copies. So we get that. But even your own personal scratch space is a terabyte. It's a, I got that right? No, I think I'm telling lies. Let me just do that. No, I told a fib. It's 150 gigabytes, and it's 100,000 files. Sorry, I was thinking of these. These ones are out of the box. That one's 2 terabytes. That one's a terabyte. So yes, and that one there's 10. That one's 5. So they're pretty big. And if your research team needs that, it's an application process that we have, and you can do that. So disk is not an issue. And even when your job runs, there is a thing called a temp directory, which is available to you, and it's an unlimited kind of bucket. Well, it's not unlimited, but it's bigger than most people have ever been able to. Well, no individual has been able to fill it up. Perhaps collectively, a bunch of big simulations running at the same time might have pressed it, but that stuff disappears at the end of each job. So it's auto sort of cleaning. Some of the challenges, of course. So you've got all this goodness. You've got lots of cores, lots of RAM, lots of disk, and lots of it, and fast disk. It's on high performance platforms, and then you've also got easy use of the RDM. So you gather up your outputs that you need to keep but basically any data set that stands between you and graduating or you and your next postdoc are going to require that you keep that data in a good place, and the RDM is the good place. So some of the challenges then, of course, you're then working across. So you've been used to file paths and locations of things on your laptop. You need to kind of address that. There are some tricks. I've done projects where I've had a file that I've sourced in an R code snippet that I source in, and then it knows what machine it's on, or what type of machine it's on, and then sets some paths and things accordingly. So yeah, so you might have to make some modifications. You need to locate where the R is installed on the HPC. It's not unlike a laptop or workstation. It's not automatically added to your path. So you need to know how to. I'll demonstrate that in a moment. And there's also a bit of a vexed issue. So when we bought phase one, the type of nodes that are in phase two were cost prohibitive and may not have even been available widely. 12 to 15 months later, we went to phase two and we bought the newer model. So there are some differences there, and that's caught a few people out, particularly our users. So there are some tricks to do with where you build the R packages so that you're able to use them anywhere. And the other thing I've noticed is this idea of, because often we've got this beautiful sort of nested for loop, and it runs beautifully on the laptop because you're not the limits of the for loop are not that great, and that means that you've got when you take that over to try and run more of it, it's then running on a single node, and there are ways, and I'll have a bit of a sample of it later on, just how you can kind of strip out some of that, kind of invert that sort of nested for loop and sort of break it out so that you can get more done more quickly. And so yes, it's to use R on Bunya. It's so if you're on Bunya, you type capital R, nothing happens, or something does happen. It tells you it can't find it. And so what you need to do is run this thing called environment modules. And basically what we do is, I might make that a little bit bigger. So you do we don't need a module purge, but it's always a good idea. You shouldn't have, well, if you've just logged in, you shouldn't have any modules loaded, but maybe your environment is set up a bit weirdly. You do a thing called module load. Module load, although the software has the capital R, the module has the lowercase. We use lowercases, it makes them sort better. It's version 4.3.3, so this is a fairly new one. And the rest of that is an indication of the pedigree. So it was R version 4.3.3 built with a tool chain called GFBF 2023A. It's a detail, it doesn't matter, other than that you will find that this tool chain, this GFBF tool chain, has been used and it's compatible with other tool chains that mean that when you start building the software, start building your own packages for R, then it will get it right and it will work. And the only caveat on that is that you need to build them on the computer architecture that makes the code more transportable, and we'll talk about that in a minute. So if you use a command called which, it will tell you which R script, and you can see it's in some weird place. Doesn't matter. The nice thing about this modules business is you don't have to care about where it lives. We take care of that, and we write the module file, and so if you do module load R 4.3.3, etc., you will get that will be found. The R script command has been found, as is the R command. And so you can do very simple things. You can R script so I've got a little demo here, 1 + 1 is 2 and 2 + 2 is 4, and thankfully it works out all right. And so that's a straightforward sort of interactive use. You'll notice that I ran this on one of the interactive nodes. So even though this is a tiny little demo, I didn't want to set a bad example. So I made a point of getting myself on an interactive session started and then running it there. So so then the next issue that comes up is packages. So there are a lot of packages, like I'm talking about 1,200. 1,200 R packages that are already built, have been built to sort of exacting sort of standards by their automated build system. So you just got to make sure you can find them. And so I've done this here. I've loaded a different version. So this is version 4.2.1, built with the FOSS toolchain. Details, doesn't matter. Again, it finds which R command. I run R. It looks a lot like the console in RStudio, and I then ask it to show me what the library paths are. And there are two at the moment. There are two. One is my personal space, and that's where if I build anything that is not provided centrally, it will go in there. And if I look for them in so something like tidyverse will be in that location. I don't want to scare you off, but it is important. Maybe I'll just highlight this. This is the sort of the important fact, and it is a feature of Bunyan now that we have more than one type of CPU. Even though they come from the same company, they've got a different internal architecture, and so if you build code on EPYC 4, it will not work on EPYC 3. The build on the new won't work on the old, but build on the old and it'll work on both. And so there are we've got some tips in how to do that. But don't build things that you don't need to, because as I said, it's about 1,200 of these packages. So this is the R library in that central location. And you can see some familiar looking things there. There'll be, I'm sure there'll be a tidyverse, there'll be a, well, take your pick really. Tidy graph, tidy select, tidy text, tidyverse. There's a lot of stuff. And it's still going, there we go. So you just need to make sure, and I was helping someone recently who had done this kind of unknowingly. They had a .r profile file, and that was actually ignoring these. So you need to make sure that if you are playing with your library path, that you do it in a careful way, so that you don't lose and end up ignoring this whole pile of work. Because you can build them yourself, and also watch the dependencies equals true thing, and make sure that I think at one stage I was actually taking the lib paths and modifying and actually swapping the order of those two things. So swapping this so that this one got read first, and then it would go to there. But I don't know that I really wasn't as familiar with R as I am now. So back at that stage, that seemed to be necessary, but maybe I just was overreacting to what I was thinking. Okay, so next point is how you actually access R. And as I say, there's the command line interactive batch job. So it's command line based. That's how I got on Bun 48048. And basically it's a thing that's described in the user guide. So you basically, it's a two-step process. You have to do both steps, otherwise the wheels fall off. So you have to salloc, that means allocate me some resources, please. And then when those resources are available, then srun whatever the thing is that you want to run. And what that normally does is gives you a terminal on the compute node, and then you can do module load for the software, and then use the R script or R. You can also use regular batch jobs, as described earlier. But your R code cannot be expecting you to press yes to continue. You have to remove all that sort of interactivity. It has to be self-sustained, self-contained, and able to run on its own with all the paths declared internally. And then you create a batch job script, and we've got some examples over on the user guide. Oh, there we are. Oops, I'll pass it. So there's some information there about how you submit jobs. The key ingredients, you need to have a bunch of these lines that all begin with a hash sbatch space, and then you specify the number of nodes, the number of tasks, the number of CPUs per task. the amount of memory and wall time and all sorts of things. And you put those together, and there's some examples down here of simple scripts. So something like that, and you can even press that button there. You'd be amazed the number of people who have copied and pasted this and got it wrong, and there's been some typing mistake up in here. So these things are just indicative sort of numbers. That's a 1 hour wall time, 10 gigabytes, 1 CPU. You can modify those, particularly if you're going to use like parallel to do a for loop across multiple CPUs. Then you would probably want CPUs per task to be 8 or 12 or 96 if you want. And most of the rest of it is pretty straightforward. And then there's these 3 parts to it. The SBatch is the sort of, well, the first line tells everybody what language is written in. These lines tell the batch system what you're asking for in terms of the configuration of the computing space. And the rest of it is what happens when the job actually starts running. And the simplest thing would be module load and then S run R script, something or other. So that's a pretty straightforward. So if you wanted to use 12 threads, then you would use CPUs per task of 12. And then the issue of the EPIC 3 and the EPIC 4, if you, in order to build, you can specify EPIC 3 for building, and then you'll be able to run anywhere. And that's probably the most convenient. It may not perform as well. It might be better to have, but there are more. The totality of EPIC 3 and EPIC 4 nodes is a big number, whereas EPIC 4s are in the minority at the moment. So you would probably wait longer. Okay, let's go back. There we go. All right, so then the new shiny thing is Bunya on Demand, and that is a fully graphical user interface for getting to Bunya. It also provides a nice little file browser thing, and also a nice thing is you can get just a basic terminal window in the browser as well. So you could potentially, as long as your phone's in a plastic Ziploc bag and you're sitting at the beach, you could probably work on your thesis and your calculations while you're sitting on the sand. And you could do some basic things. You probably wouldn't want to be using, a phone screen to run a fully graphical user interface, but you could use this little terminal window to submit some more jobs or check on the status of jobs. So to say, the Bunya on Demand is accessed via a web browser, and it has a bunch of menus. There are applications. If you go into the fully immersive sort of graphical environment, then there is a menu of applications, and RStudio was one of them. But you can also just open up a terminal window and activate the software that way, and that looks like this in. Can I get that link right? Oh, there it is. Yeah. So that's, well, it's got this big text window in the middle of it, but it basically looks like a Linux workstation. It's got, a computer and home directories and access to collections. It has some tools and it has some menu things over here. So the applications includes a whole bunch of things, things like Fiji if you're into image processing. But basically all the applications that were on what was called the CDL have been moved across. But RStudio is also in there, so you can actually pop up RStudio by finding it in this very long list of applications. Or you can just open a terminal, do the module load for RStudio. That will activate a compatible version of R, and off you go. And then you just type RStudio, and then you get something that looks very familiar. It's a little bit Linuxy, but it works, and you can do that quite happily. And have quite a productive time with it. Wouldn't recommend. I mean, if one of the things is that you can run, you want to use HPC, you can run lots of the same thing. Then you wouldn't go about it using just RStudio, but you might want to use RStudio to test and to check that everything, all the bits are working. but you would probably want to go down the path of those sort of self-contained job scripts for instead of using RStudio to run lots and lots of it. Okay, the final point is that often R code is used as part of a parameter sweep situation, and that's often that's the trigger for needing to move to a bigger machine, because you suddenly think, oh yeah, gee, we could do this across all the species of insect, or all the regions of the world, or or the 4 seasons of the year, or a bunch of different climate scenarios. And we had somebody a couple of years ago had a conference deadline, and was studying the migratory habits of crocodiles in rivers up in Northern Territory. And so each crocodile had a unique identifier, and they'd monitored them for some of the time, and then they were using R to do sort of traveling salesman type modeling of where the crocodiles would go next. And it was fascinating, some of the sort of trajectories and things. They're not as I can't remember it was surprising, some of the that they either were or weren't as territorial as you might think. They sort of tended to stay out of each other's way. But yeah, as soon as you start combining variables like this, and I did have a student came in very excited about this idea of using HPC to simulate something or other, and they were going to do a parameter sweep, and they were going to do this many of this and that many of that and this and that. And anyway, okay, well I'll do a little bit of due diligence, and I worked out that the number of combinations they were looking for was more than 10 to the power of 100, or 10 to the power of 99. So basically, it wouldn't fit into a calculator, and that was a problem. So, and it's you can see why, because you've only got to go 1,000, 110, and you've got yourself 1,000,000 combinations. It's all doable. It's just how you go about it. And obviously how long to do something takes to run. If it's going to take a day to do each one of those, and that's 1,000,000 days of CPU time, that's going to be hard to get done in any sort of reasonable time frame. With even if we get to 10,000, we probably will get to 10,000 cores with phase 3, but you can't have the whole machine to yourself. And so if you're doing this sort of thing and you're using the library parallel, you're possibly able to you're able to fork 96 of those running in parallel, but it's still going to take a long time to get through, or a lot of iterations. Now, if each iteration is fairly quick, even if it's a few seconds, it's still going to be it's a task. And so what I've advised people to do quite a few times in this, particularly in the sort of spatial ecology sort of area, but just in general, if you were to strip one of these variables away from the loop and put it as an external kind of parameter, and then we use a thing called job arrays. I'll explain a little bit how they work, but you can then ask the batch system to provide the value of I, every value of I from 0 to 999 or 1 to 1,000, and it will then you can access that value of that in the current the current element of the job array, and you can pass that in as a parameter. And that's been sort of shooting fish in a barrel, and it's just too easy to do. You basically just change your code so that it accepts one command line argument, which would be the value of I, and you use a function called command args, and you should do some checking that it's a sensible value, and etc. But then basically for each value of I, you can have this. You can then just run RScript. This RScript, the name of your script, your modified script, and the value of the parameter I, and do that for the 1,000 values of I that you wish to use. Now you can do that. You could actually do that by submitting separate jobs to the batch system, like 1,000 separate jobs, if we're using this as an example. But there are some smarter ways to do it. There's a thing called job arrays, which are as the name suggests, it's an array of jobs. So it's a vector that contains the elements of the vector are individual jobs with a different value for the index. And then you have access to the value of that index, and you can use that in the current, in each job as a distinguishing parameter. And so that's how you can actually get the value of I from the batch system. And it works. It's really straightforward for integer parameters. And with a little bit of imagination, you can work with non-integer ones as well. There is a limit though on Bunya with job arrays are limited to 1,000 elements. They get unwieldy if because it effectively takes what you're asking for and then blows it out to 1,000 separate jobs, and then a kind of like a wrapper job, a job in the batch system. So it gets pretty brutal pretty quickly. We have a tool which it was available and was very popular on amongst some of the R users actually, but also people that were doing stuff with MATLAB and a few other things. A tool called Nimrod. Our previous director's sort of pet project for quite a while now, and we had it established and running. It's just because of the partly the enhanced security model on Bunya. It's been a bit of a journey to get that. But hopefully later this year we'll have a thing called Nimrod, which makes it really easy to do sweeps over combinations of parameters. So you can do things like floating point values. You can do sets of character strings. You can effectively do an ls on a listing of the files in a directory and get the and use that and populate a column in a you end up populating it. It has its own database, so it creates a table in a database with all the combinations of the parameters, and those parameters can be pretty much anything that's you can imagine you might need or want on a HPC system. So it can be file names, it can be character strings, it can be floats, it can be integers, it can be logicals. I'm sure there's some others. I just can't think at the moment. Basically, it's in a nutshell, it's the possibilities that open up when you put two of my favorite things together, R and high performance computing. You put those things together, it's happy days. It's just the first few days are a little bit of a struggle, but it is well worth the effort. If you're doing anything at scale, you're going to need to be able to do this and do it well and do it. And there's a lot of support with the hacky hours and the virtual HPC sessions. So there's always our help and the RUG meetings. So we've got avenues for getting help with this stuff, and you just got to get on board. So thank you. Happy to take any questions you've got.
Wonderful, thank you, David. Hopefully that has at least shown people something of the world that is out there in terms of HPC kind of stuff. Does anyone have any questions? I don't think I've seen any questions appear in the headstock at this stage, but I'm happy for people to put things in the comments, in the chat, or anything like that.
Often it's the case that you really kind of you only find out what you don't know when you start to when you sort of immerse yourself in it. But yeah, in terms of that, I've observed this journey, and there's always a few people trip over a couple of key points, it's a learning, and there's only so much you can kind of preemptively warn people of, we try and catch them before they fall.
I don't see any questions coming through just yet, so I've got some questions that I might ask if no one else has any. I don't. David Mothers asked the question: what is the longest job ever run on Bunya?
On Bunya, 2 weeks. That's the wall time limit on a CPU node. It's 1 week for a GPU node. I'm not sure whether we're entering into well, there are situations where the computation just doesn't finish. It's not well, I guess it depends on so if you can if your problem that you're computing lends itself to what's called checkpointing, so at the end of 1,000 iterations of something, you might stop and write a file out. If you're able to restart the job from that place, that is a much saner way to work. There was I think they're still in the Department of Chemistry. There was a professor in chemistry had a small HPC sort of system in their lab. Their jobs ran for 24 hours, and that was it. And so everybody's jobs used to checkpoint every 30 minutes. And so sometimes they got to 23 hours and 58 minutes, and then it wrote something out, and then they could start again, and they didn't lose the last 28 minutes. But it was, there was potential there to lose the last, amount of work if you didn't get to the checkpoint in time. But it's about sharing the resources and making them available to people. But it's long wall times are problematic from a maintenance point of view. So we actually take Bunya and turn it completely off and redo stuff to it every 3 months. So but back in the bad old days, we would have people that their job would run for a month and a half, and would just fail randomly, and they'd restart it, and it would run for another month and a half, 2 months, might fail again. And so it was literally taking months to get anything out. Now, I get that some problems are not computable in a way where you can restart, and there are some technologies that we can use. To be honest, those sorts of problems are possibly good candidates for the National Research Cloud, because it's a virtual machine, and you can actually take an image, a snapshot of the virtual machine in its state, and restart. So, and we did flirt with doing that actually on one of our several HPC systems ago. We were in, it was very early days of virtualization, and the Research Cloud didn't even exist then. So that's how old it was. That's been going for more than a decade. We ended up running virtual machines, so people could run a virtual machine and run their calculations in a Linux virtual machine running on a Linux HPC machine, just so that they could then every Sunday night we used to snapshot them and actually automate a kind of like a backup copy. And then if it failed in the next week, or the wall time ran out, then they could restart from that same place. It was a kind of a sledgehammer to crack a walnut, but it is a problem. In the National Supercomputer Centre in Canberra, they had somebody, I don't know how many years it took them, or how many person years it took, but it was a long time, a lot of effort to modify the batch system software. They were using an open source version of it, an open source, and they added this extra stuff so that they could actually take a complete kind of snapshot of the memory and the stacks, and then and save it away. That was a very specialized thing. Of course, when that person left and they changed machine, they then had to move away from that, which was a great shame. But it was pretty good at what it did. Question there, Bunya can scan jobs and order them as necessary. So the kind of the cult that is batch system scheduling, I'm not that familiar with from my observations. If your job is at the top of the list of queued jobs, and a suitable space becomes available, then your job will run next. But it does sort of the variations on the theme. They read down so many in the list. When it's a really busy time, there's no point kind of looking all the way to the bottom. But it is one of those things. People sort of think, why does my job wait and somebody else's job starts? And I've had situations where literally it's been it's a flip of a coin. Actually, it's not a flip of a coin because the coin's biased. There's this other thing, I didn't want to mention it, but I will. There's a thing called fair share, and so everybody who uses the HPC has a metric, and that metric starts off at the value 1.0000, and if you do lots and lots of work, then the number goes down and down and down until it gets to 0.000. And then it's sort of like a sort of radioactive sort of half-life. It then sort of slowly comes back. If you don't use it, it kind of comes back up again. But the time frame for that is a bit long. So one thing that I would encourage you to do is test, test, test. Don't just go nuts in your first week, because it could put a big. I mean, we've seen this happen, particularly in the early days. People got on, their fair share metric was very high, so if they're in competition with anybody else, they always got their job started, and they had a really happy time. And then their fair share metric came down and started to be less than other people's, and then it's an unfair fight. Well, it is actually fair, but you've used it a lot, so then you should wait a little bit longer than someone who hasn't used it as much. And if you blow your fair share quota, or your fair share metric, if you dent that too much in the first little while running jobs that actually aren't successful, or running jobs, because you pay for the time that the machine is unavailable. So if it runs for a week and gives you no result, that's a week's worth of dent on your fair share.
So you're suggesting that people should do like little tests to make sure
Absolutely.
that the little thing will work before putting it in for the whole thing.
Yep. And don't just jump into the deep end of doing 1,000 element job arrays without testing that the first two work. It's a common, because it's such a mess to clean up, and you're able to clean them up. You have to delete them all, but it's just be testing. And when I do the introduction to HPC training, I want you to be mindful and kind of and aware, but I don't want you to be fearful. I don't want you to be sort of so timid about using the thing, because ultimately it is just a computer. We can reboot it. A few people will complain for sure, and we've got these rules. And if you play within the rules, if something goes wrong and wasn't foreseeable, nobody can hold you. Nobody can really yell at you. It's just unfortunate, and that's what we used to in research computing. We're not running the university's payroll system. We're letting people who are less familiar with computers. We give them a login and we say, knock yourself out, and they do sometimes. And we just gotta and we deal with it, and otherwise people can't use it for if we kept it only for experts, then there's a whole lot of stuff that research that just wouldn't happen. So just be mindful, and hopefully get confidence in the platform.
Right, but don't be afraid to play, it sounds like.
Oh, hell no.
So
Particularly in that sort of interactive environment, because you either the open on demand or the interactive job session. That's kind of like your own little personal. If you went for 4 cores, and you could mimic the laptop that I have. So you could go 16 gigs of RAM, 4 cores, and have effectively a little sort of command line sort of environment that looks like a laptop running Linux. And then you could do some testing there. You could look at utilization. You should never be expecting that stuff is just going to run faster when you put more cores under it. If you're using parallel and it's a parallel loop structure, yes, it will by and large. But if you're other sorts of simulations that people do, they just assume that putting more and more cores under it will make it run faster, and sometimes it doesn't. The communications get so frenzied between the participating elements that it actually slows down. It can actually be worse. So there's a general sort of there's a speed up curve, so things get faster for the first little bit, and then it sort of tapers off, and it actually plateaus the performance. And depends what you're doing with R, and how you're going about it. But it could get saturated due to data or memory.
So that loop script that you put up as the little example, that would still run faster on the HPC, even if you weren't doing anything special than it would on your regular computer.
Compared to the laptop that I have, yes, because the
Yes.
CPU speed is faster.
Yeah, I assume most people probably have a similar laptop than that. So
Yeah,
it's I guess we use R both to do like statistics and different analyses and things like that, but it's also to enable us to uh, do those repetitive processes. And by
mm,
using HPC, we can do a lot of those things a lot faster.
sure, sure. But yeah, people are sometimes a little bit sort of disappointed when they find that the CPUs, particularly in our previous machines, what we've gone for is number.
Yep.
So we've actually gone for and cost, operating costs, because if you've got the bleeding edge CPUs are often the hottest ones, most energy consuming, and they cost the cost per unit is disproportionate. So we often in the past have bought and continue to, I suppose, we buy kind of one generation or one version back from the bleeding edge. You get good value for money,
Yeah.
and certainly our machine called Baring, that was that they were the deliberate choice because it was the biggest machine we up to that point was the biggest machine we'd ever purchased. It was about 3,000 cores at that stage. That the power bill was going to be enormous, and so we're considering our footprint. So we went for high efficiency CPUs. They were running slower, but we could afford more of them, and we could run when they weren't busy, they were then cool. They'd calm down and not consume so much energy. So
So if someone wants to get started with, they've got their R code that they're running for their project. It's
yep.
all running. It runs on their computer, but it means they have to sit their computer there for 48 hours while their model runs through. Um, what would be their first step to getting using a HPC with you guys?
Well, first step is to apply for an account.
Yep.
So there's a process. I'll just pop it in here. RCC support at uq.edu.au. If you email that address, that will come into our ticket system. It's the CRM sort of thing, the same as other parts of the university are using for support and engagement. So if you're send a ticket in and say, I'd like to, I've got R code to run, tell them I sent you. If you want, it's a bit of a no-brainer. If you're a UQ researcher and you've got code that you want to run and you're currently frustrated or limited or both by what you've got available, and it can be, I mean, people come to us that are using department HPCs, or computing resources, and they've either and the other thing that we're getting now, and the reason why I suspect why the Bunya on Demand is so popular, is a lot of schools and institutes are now telling people, no, we're not going to buy you your high-end technical workstation so you can then just compute on your workstation. We've heard about this mob called Research Computing Centre. They run a thing called Bunya. Go and find out about it. And so, and of course, then we had to, and people saying, yeah, but I need a visual workstation, and that's fine. And now we have it. But so that was part of why it was just it's not a good use of funds to tie up $10,000 in a workstation on a desk, just so someone can tinker with it. We provide and run these resources. Then it's just a matter of scale, whether we've got enough to deal with the peak loads and how long people are, that say capacity planning is a little bit tricky in the current environment. But yeah, so apply for an account. In the process, attend the intro training. We've got documentation online. Probably the other thing you want to do concurrently, because it is a bit like learning a language or learning an instrument. You need to practice. You need to be comfortable in the Linux environment. You can do a lot through non-terminal environments, particularly if you're going to use RStudio to do your coding in the graphical environment. But sooner or later, you're going to have to. There are things you need to do that will require command line competence. So we encourage people to. And my colleague Marlies has done a whole bunch of little video clips on the QSIF's YouTube channels where they ended up. Not sure why they ended up there, but that's where they went. And that stuff's all linked off the user guide for Bunya. So if you
You want to put the user guide in the chat?
yeah, I just
And
think
I'll also link that onto the UQRUG website.
let's get back to. Yep, that's the shortest version of it.
So would you say that a good way to get potentially a good way to get started with using the HPC would be to start with that RStudio graphical interface,
Oh
just
yeah,
so that you
yeah,
don't
yeah.
like it's not as big a learning curve to
That's
begin
right,
with,
and
and
it's a
then you can
familiar
see
environment. Yep.
as you see the benefits of using the HPC, you then go, okay, I do need to learn how to use Linux and go from there.
Yeah, I think so. And yes, with because that's been a gap that's been too it's been difficult for people to jump over. Whereas there's a couple of stepping stones now in using having RStudio available at all. Um, there You might find things like the links off to external browsers and things. I haven't actually tested it thoroughly on the. I think it should work under Open on Demand because there is a browser. You might actually have to set something in your profile to be able to find it. But yeah, the word difficult. So when I've installed RStudio on previous HPCs as a software container, um, some things like following links out to external documentation didn't work seamlessly, but you can just take the link and paste it in, so it wasn't a showstopper. But yeah, it's a familiar environment for people, and they and we get that. And then if you can get and maybe do the first step would be to think, well, where am I going to put my data? And there's a storage user guide is a separate document now, and that'll help you to work out what's RDM, what's home, what's Scratch, how big are they, what sorts of things should I be putting in Scratch, what sort of things should I be keeping in my home directory. So yes, if you sort of start there, so use RStudio with some awareness of where stuff lives on the HPC, and awareness of well, I suppose if you load the RStudio module, you're getting a complete R backend with all those 1100 or 1200 extra packages already pre-built. So as long as you don't mess up the search path, um, which has affected a few people in recent months, you should be fine. Yeah, and start there, and then think about how you might take that, get it to the point where it runs happily, and then if you want to go large with it, then you're going to have to take the code is the code. It's then just about creating a job script to run the code.
All right. Excellent. Cool. Well, hopefully, if you weren't aware of HPC stuff before, David's made you aware of it and hopefully shown some of the ways to get on there and the advantages of going down that pathway. Looks like some people have to drop off, but thanks for coming along, Kyle. It's always good to see you. Um, does anyone else have any other questions for David while we have him here? Look like it. As David did mention, if you do want to get into using the HPC, it's on the wrong screen. If you do want to get into using HPC, you can go through those GitHub docs that David shared. So you can find all the details there. You can contact the Research Computing Center through their email address, but also every Tuesday afternoon, there is the UQ Hacky Hour, which is run by the RCC, and that's 3 to 4 p.m. And it's a variety of technical help that you can get help with. But David is there every week or almost every week, so you can get if you need more help from people like David, you can go specifically to Hacky Hour to get help with HPCs as well. All right. It doesn't look like people have questions. I could keep asking David questions about HP stuff all day if we want to.
Can you hear me?
But I just wanted to quickly flag that this will be my last UQR user group for quite some time. I will be going on some extended leave next month, so I won't be around, but you'll be in the capable hands of David, Valentina, and Luke will also be returning. But yeah, it's been a lot of fun running UQRUG, and it's wonderful to see everyone coming along every month and getting to learn lots of things. So thank you all for coming this month, and hopefully I'll see you at one in the future, and hopefully you keep coming.
Yes, I would like to say take a couple of minutes as well to say thank you, Nick, for running RUG for almost 2 years straight, implementing beautiful initiatives to, get, encourage people to come, such as coordination and delivery of this short talks that happen every time RUG happens, as well as some fun initiatives like the silly RUG and the competition that happened at the end of the last year. So that incorporates a playful, fun twist that I think that is so helpful when you're trying to learn something like programming. So yeah, thank you, Nick, for all your hard work for RUG and all the contribution for everyone.
Thank you. It's been a lot of fun. It's been a really fun group to be part of and community to run and get people having fun and engaging with R. Thank you. I'll be overseas for a fair bit of it, but maybe I can drop in via Zoom every now and then. Who knows?
Don't do that, Nick.
Yeah, it's probably good advice.
Just enjoy yourself overseas. Don't think about your kid.
Yes, you deserve it.
Thank you. Yeah, no, it should be a good break. Yeah, thanks.
Thank you very much for filling in for today as well, Nick, because Nick has had to work from home because he wasn't 100%. So do thank him for making the effort, not to just say, yeah, I'm going to have a sick day.
Well, I mean, I half did that because I didn't I've been a little bit out of it with the vertigo, but no, I don't want to miss UQRUG, not the last one. Not my last one, not the last one. I assume there will be a May one. I'll be lining up to get some other people to come in and do some special guest talks while I'm away. But someone else is gonna have to pick up that regular shift of learning something on the spot and running it. But it's up to you guys going forward. Cool. Well, do people want me to keep asking David Green questions about HPC stuff, or no worries, Senpai. Thanks for coming so often. Yeah, what do we want to do? Like, we've got half an hour left. People want to wrap up early. Do we want to keep asking David questions? Does anyone have any other random R questions? I know no one's put anything in the thing for this month, but any other questions at all?
I had I have sort of taught the kind of standard sort of software carpentry take on Nitar, and then I thought, oh, it's nice, but I'd like to do a little bit more formatting, that sort of thing. And then I sort of ended up down a rabbit hole. Probably, a disproportionate amount of the time I spent was trying to get a nice color and font, and I was you can see my tabs were probably giving a little bit away about what I was trying to find. But it's yeah, I'm quite impressed with what they call it's BSlib is the way
Yep.
that you
Bootstrap.
add these directives into the top of your R Markdown. Yeah, and the same sort of approach works on Shiny apps and all sorts of other things. So yeah, I was once I sort of knew enough to be dangerous, then I at least managed to change that. Although I was staring at this, the one called there's a template standard template is a quartz, but it's got this kind of pink to blue to pink kind of transition across ways, and like it's just too far. And then, but all the other ones were a bit dull, so I ended up using Mint, I think, Minty, I think was the one that, and then modified the background color. So that was an interesting little exercise.
Yeah, that's the big advantage using things like knitr and things like, well, any kind of free program thing is you can really quickly change the entire theme of your document that you've created just by swapping in a different Bootstrap library. Yeah,
indeed.
That's cool.
Zoe's got a good question here. So you got your RDM set up, and yeah, the RDM is a kind of different department. Although we actually operate the storage infrastructure that provides the RDMs that begin with the letter Q, and they're actually in the same room as at the computer center as the Bunya HPC. But yeah, it's a separate thing. So the email, yeah. So if you apply for the for Bunya access, if you're, it doesn't really matter. You can only have a Bunya account if you're a graduate student that's got a staff and a student credential. And the rules vary from sort of location to location around the campus, but you know, it kind of makes sense for you to be running stuff for your, if you're a graduate student, then running stuff for your thesis as your student ID. Now, if your RDM is actually set up in your staff, if you have a staff credential and it's set up in your staff credential, that's okay. You just collaborate with yourself. It's a pretty straightforward thing to do. You just get on the RDM portal, and so none of that stuff is the stuff that we handle. But if you're once your storage facility for the project is HPC compatible, yeah. So all right, well that'll be easy. So as long as your staff credential is so you just basically go through the process of applying, and there are some things you'll need to, like there's details like field of research codes and stuff. The form is fairly comprehensive, but it'll allow us in the future to be able to kind of, you know, look at the usage that people have made of Bunya and sort of do all sorts of statistical analyses. So yeah, that's people are finding that the hardest part is actually finding a new set of FOR codes, because I haven't done that sort of stuff for a few years, and 4 digits became 6, and a whole new scheme. So I had to dig into that too. I think it happened when, yes, I went back to my RDM. I have a test one that I use for demonstration purposes, and I went back to it, and after the upgrade, they upgraded the RDM sort of mechanisms, and so suddenly I had to provide new FOR, new format FOR codes for stuff, and I found myself sort of digging into the spreadsheet trying to find where my thing had gone. But yeah, it's the actual storage is co-located with Bunya, so it's a very good place to be. In fact.
So basically, Zoe's RDM has access.
Yes, if it has a letter Q in the front, yeah, if it has a letter Q in the name, then it's automatically going to mount on Bunya. You just have to, you know, tickle it a little bit, and then it will actually connect. It doesn't stay connected all the time, but if you need it, when you need it, it connects automatically. It's like sort of like a telephone exchange, the old-fashioned telephone exchange. Sort of plugs the wire in, and then if the line goes quiet for a while, if you don't use it for, I don't know what it is, 30 minutes or something, then somebody just pulls the plug out, and you can get it back again straight away. It's
but Zoe will need to email you to get access to the actual HPC side of things.
Correct. Yeah, we'll just send you the link for the application form. You can actually find your way to it if you go to the other one, which is rcc.uq.edu.au/Bunya. That will get you. There's a link on that page for, or there's a section about how to apply, and that takes you to the same place that we will send you. But yeah, I suppose we probably don't add much apart from the diatribe about FOR codes and supervisor. If you're a student or I guess an RA, you probably can do it in your own right. Although there's a concept. So jobs run under what's called an account code or an account string. and that's it maps to a group. So it's a group of users who belong to the same either well, they're not normally done at the research group level. So whoever you're doing most of your RA work for, they will be I guess they'll be required if one doesn't already exist because of other people in your group. You might need to create that. So it can take a few days. So it's not a case of, oh, I'd like to use Bunyip today and off you go. It's there's a bit of a run up. We tell people about a week. If it's particularly gnarly, if the FOR code could be a problem, some incomplete details. And then
right, so Zoe could sign up for that today and have access whenever she needs it.
Sure,
that's like the good approach.
It doesn't get timed out. It's I think we haven't yet got the mechanisms in place where we would be tapping people on the shoulder and saying, "Are you still there?" But if if you had the account, it would certainly make it, when you were ready to start using it, it would make it a smoother transition, because often these things, I mean, we sometimes have students who they've kind of putting it off, and then suddenly they've got one of their thesis milestone things, deadlines, and then suddenly all hell breaks loose, and they need to not only get the HPC access, learn how to do Linux, work out how to get jobs into the system and use the software, and they're doing like an intense kind of, and they have a really uncomfortable time, and it's just they just couldn't get going on the because it's if you're not familiar with it, it's a sort of, I mean, we're all guilty of that. Times we just the stuff we're supposed to do and the stuff we sort of will do because we don't want to do the stuff we're supposed to do. It's I got very, very interested in home brewing wine when I was supposed to be writing my PhD. It's amazing the sort of hobbies you develop when you
Well, it sounds like it's a good thing to do would be to sign up now before you need it.
I'd say so. I mean, as far as I know, there's no harm, and
attend one of your training sessions and then kind of play with it a little bit with something that doesn't matter, like not using heaps of resources, but like just like test it out.
And then just kind of sneak up on it slowly. It's it can be quite overwhelming if you sort of, you've got a deadline and you've got to get all this stuff done. If there's software that you need that is able to be installed on Bunya but is not currently on Bunya, that can be a bit of a delay as well.
So when you say software, does that include like particular R packages?
No. Our position is we've put the core of R and nearly 1,200 of most often used packages in an accessible combination, and then if you need something peculiar and exotic, then you can then build that yourself, and it goes into your personal library. So R is a bit of is straightforward in that respect. Now I'm thinking particularly of like software for genomics analysis. There are just so many of them, and they change so often. It literally was a full-time job. We had a team of people that used to manage. When I was was running there was a specialised facility for bioinformatics. It was like a Queensland node of the National HPC Centre, and they kind of they sort of said, "Oh, could you take bioinformatics off our hands?" So we did. They gave us some money, and we did a pretty good job. We had money to staff. We had people that would maintain and test the applications. We had test jobs that used to run several times a day to make sure that the outputs that came out were the same as we expected. I mean, that was mostly the initiative of the applications manager. Had worked in like telecommunications billing systems, and you don't want to have, you want to make sure that you're sending people telephone bills that they're everything's accurate and there's the formatting's right, and so we sort of brought that sort of exacting sort of approach to the genomics applications. So the whole stack was tested several times a day to make sure that the test outputs were the same as we expected them to be, and would raise alarms if they weren't. So that was yeah, but that was a team of probably 3 people doing that, amongst other things. But yeah, providing the application. So yes, so we're a little slower than that. We had a big surge to get from the old HPC across to Bunyan, where we put a survey out, and people sort of said, "Oh, I need this, this, and this," and you know, R was right at the top of the list, but there were other things that you know, and we had, the list was about 100, it was well over 100, and then we ranked them on the number of requests, and then we just basically worked our way down the list. It took us months, but we got to the bottom of it. But stuff comes in all the time, and it's very hard to justify a huge amount of effort to install one specialist piece of software for one particular individual, when we would like to, but you know, there's just so many other people, you know, sort of crying out for our help. So we tend to take a long time over some of those things. In fact, to be honest, it's a point of enormous embarrassment how long it's taken us to get the 4.3.3 R. When it was requested, it was 4.3.1. That's how long ago it was.
Some of these things take time.
And I tried several, because we have a preferred way of, it's sort of an automated building mechanism, and it gets complicated with software that's not available. There's not a recipe available for that specific combination of software and dependencies. So yeah, it was sort of hand-to-hand combat there. But anyway, we've got it done, and then the build mechanism is sort of something that the sysadmins have to sort of run. And anyway, it's there now. Although the set of 1178 extensions that the R packages failed to build. One of them it stopped halfway through. A thing called HMS, which must be hours, minutes, and seconds. The package for doing that failed to build. So if you are on Bunyan, maybe stay away from the 4.3.3 version for the next few days. We're just chasing down how to well, for whatever reason, that particular package is not, the source code is not downloading. So we've just got to maybe wait a few days and somebody will figure it out. I've also got copies, I suppose I could. So I went through the whole build process sort of on one of the architectures, and then the automation then takes that recipe and applies it to all of the computer architectures that we have. Yeah, it's quite a business, but what it means is that it's going to work. It passes all the tests, and then it is going to work.
Thank you. One thing that you mentioned earlier was parallelization, which people may not be aware of. So I've put a link in the chat to the September UQRUG from last year. So that's the recording of that, where we had an overview given about using parallels in R. So if people are wondering what we're talking about there with parallels, I've put a link in the chat to, and we had an overview on that one, so you can find details there. That was September, so that was, yeah, Raoul gave an overview of that, and I could put in a link to the UQRUG website that also has details about the overview that he gave that day. So if you're wanting to use the HPC, learning to do parallels is really useful, because it means that you can use multiple cores on your computer all at once instead of just using the one core. So it really will, it makes things run faster on your own computer, and will definitely make things run faster on the HPC. So if you are going down that avenue, that's another useful thing to learn. It's not completely essential, but it's going to make things faster for you.
Yeah, and it looks. In fact, I was helping someone with that only a couple of weeks ago, and yeah, I think they hadn't actually requested the right combination of resources, so they were. That was the problem, but it looks very straightforward. I think you kind of make a cluster, and then you say, okay, well, we want to parallelize this loop, and so it assigns, you know, if it's 4 cores that you've got, then it'll do 4 of the values of the loop variable on different cores, because those things are independent of each other. Yeah, it's doesn't work for everything, but it's good for the things that it's good for. It's really good.
Cool, that's good. All right, well, it's almost 2 o'clock, so I think we'll wrap things up here. As always, the next UQRUG will be in May on the last Wednesday, which I won't be here for that, but that'll be the 29th of May. I think Luke will probably be the one picking up and running with that, but we'll see what happens then. Well, you'll all see what happens then. I won't. I'll peer in from the outside. Hopefully everything runs smoothly. But anyway, thank you all again for coming, and thank you for sticking around for all of today's session and all of the last 24 UQRUGs that we've that I've been able to be a part of. It has been a really wonderful time. I've been able to learn a lot thanks to this community, and yeah, I'll definitely miss it, but I'll be back. I'll be back, that's for sure.
Excellent.
Yes. Thank you so much. Thank you again so much for today, David.
Right.
Always good to get an expert.
Two of my favorite topics, R and HPC.
Excellent.
Yeah.
All right. Thank you. Bye.